Welcome to session 1 on Lebnitz Theorem. In this session we are going to study some important examples on Lebnitz Theorem and the statement of a Lebnitz Theorem. Okay, first let us take one example which question appeared in 2019 of BSc first semester. State Lebnitz Theorem, and if y is equals to log x by x, then prove that yn is equals to minus 1 raised to n into n factorial divided by x raised to n plus 1 of log x minus 1 minus 1 by 2 minus 1 by 3 etc. up to minus 1 by n. First, let us see the statement of a Lebnitz theorem. The statement of Lebnitz theorem is, let u and v be any two functions of x, then nth derivative of u into v is equals to u into nth derivative of v plus nc1 derivative of u n minus 1th derivative of v plus nc2 second derivative of u n minus second derivative of v etc. up to ncn. So here ncn value is 1, so I have not written ncn. It is nth derivative of u into v, and we can also write this one in short form as nth derivative of u into v is equals to u into vn plus nc1. Let us differentiate this. It's very easy to remember this formula. That is, nth derivative of product of two functions is equals to first function as it is nth derivative of second function. You remember only this first term. So then plus nc1. You just see the previous term to write this next term. That is, you differentiate this u and reduce the degree of this vn by 1. That is vn minus 1. Plus, again to write this next term, what to do is here, you just differentiate this previous term u1. That is, derivative of u1 is u2 and reduce the degree of this vn minus 1 by 1. That is vn minus 2 etc. up to un into v. So no need to write this, no need to remember this definition also, isn't it, last term. So this you can understand while solving the example. So once I'll write this one in an easy way. That is, you see here, nth derivative of product of two functions is equals to nc naught, that is 1. So u into vn plus, to write the next term, don't remember this formula, because here when you see this formula, then you can think that it is very difficult. It is not like that. Only you just remember this first term, that is u into vn. You can write the next term by seeing the previous term, that is nc1. You differentiate this u, that is derivative of u is u1, and reduce the degree of vn by 1. So degree of vn means the nth derivative, that is reduce the nth derivative by n minus 1th derivative, that is vn minus 1. Then plus nc2. nc2, you just, to write this next term, you just see the previous term, that is derivative of u1 is u2 and reduce the degree of this n minus 1 by 1, that is n minus 2 plus etc. up to last term is ncn, that is 1, and un into v. It is not vn, it is simply v. So I hope you remember this formula very easily. Just one term, and increase the degree of u by 1, reduce the degree of vn by 1 in successive terms. So, and here while selecting u and v, you should be very careful. So you have to select the term u such that its derivative should reduce after some differentiations, and that is you take v as the term whose nth derivative is known, isn't it? So algebraic functions you can always choose as first term, so that its derivative vanishes after some terms. Okay, so this is the statement of a Lebnitz theorem. Here the subscripts denotes the order of derivatives. Okay, let us take the example of this one. Let us take here, in this question it is given here as y as log x into 1 by x. You just differentiate this. That is, here it is asked to find its nth derivative. No? Here it is product of two functions. Log x into 1 by x is product of two functions. So Lebnitz theorem can be applied for the differentiation of product of two terms. Let us take yn as nth derivative of log x into 1 by x. Okay. So here this is like u into v. This is u and this one is like our v. You know, first term is u, that is log x, into nth derivative of 1 by x. Then plus nc1 derivative of log x into n minus 1th derivative of 1 by x. Then plus nc2 second derivative of this first term, the second derivative of log x into n minus second derivative of 1 by x, etc. up to this is nth derivative of, you know, here nth derivative of first term log x into v. V is 1 by x. Next is only simplification, isn't it? So this log x as it is nth derivative of 1 by x. So I hope all of you know this nth derivative of 1 by ax plus b. So this is the formula we use here. So we know nth derivative of, that is nth derivative of 1 divided by ax plus b. This I have done in previous video also. So that is minus 1 raised to n into n factorial into a to the power of n divided by ax plus b raised to n. So this is the nth derivative of 1 by ax plus b. This 1 by x is exactly like this one. 1 by x. A is 1, b is 0. You just compare these two. Okay, it is exactly like in this form. So its nth derivative is minus 1 raised to n into n factorial into a to the power of n. Here in this term a is 1. A is the coefficient of x. That is, it is not necessary to write 1 to the power of n. So I left that one. And divided by this denominator ax plus b. Here ax plus, in place of ax plus b it is x. So it is x to the power of n plus 1. Then plus nc1. nc1 is n and derivative of log x is 1 by x. N minus 1th derivative of 1 by x. See here, nth derivative of this one is like this. N minus 1th derivative is just here. N minus 1th derivative means you just replace n by n minus 1 like this. This is n minus 1 factorial and this one is n minus 1 like this. You just replace n by n minus 1 in this previous term, you will get this one. That is minus 1 raised to n minus 1 into n minus 1 factorial divided by x to the power of n plus 1 is there. Sorry, this one is, previously it was n plus 1. So, and this one is minus 1. So, it is n plus x to the power of n. That is n plus 1 minus 1. 1 get cancelled. It is simply x to the power of n. Then plus nc2. You know, this nc2 means you have to start with n, write two terms, n into n minus 1. See here, two terms it is, divided by, here we have 2, no, it is 2 factorial. This is the short form of writing nc2. You know NCR formula. So after simplification you get this one only. You know NCR is equals to n factorial divided by n minus r factorial into r factorial. So this is lengthy. So this is the short form of this one. So nc2 is n into n minus 1 divided by factorial 2. So it is n into n minus 1 divided by factorial 2 and this next term is here derivative of 1 by x. Derivative of 1 by x is minus 1 by x square into n minus second derivative of this one. So that is replace n minus 1 by n minus 2 here. So that is minus 1 raised to n minus 2 into n minus 2 factorial divided by x to the power of n minus 1. Reduce this n by n minus. In place of n you just put n minus 1. So then plus etc. That is, you just reduce the degree of this one, no, by 1 in successive terms. So etc. up to this u as it is. U is 1 by x. Sorry, v is 1 by x. V into nth derivative of u. Nth derivative of log x now it is. Nth derivative of log x and into v. V is 1 by x as it is. Nth derivative of log ax plus b also we know. Nth derivative of ax plus b is minus 1 raised to n minus 1 into this is n into n minus 1 factorial, that is n factorial it is, isn't it? It is n factorial divided by x to the power of n. We know this one, nth derivative of log ax plus b is equals to minus 1 raised to n minus 1 into n minus 1 factorial divided by ax plus b raised to n it is. So it is minus 1 raised to n minus 1 into n minus 1 factorial divided by x to the power of n, and this 1 by x as it is here u. So let us simplify this one. Minus 1 raised to n into n factorial, first term, so that is divided by x to the power of n plus 1 into log x, then plus this minus 1 raised to n minus 1 into this one. See here, minus 1 raised to n minus 1 is there. So we can add this one as minus 1 raised to n into minus 1 to the power of minus 1, and this one is n into n minus 1 factorial, then plus second term as it is here, n into n minus 1 factorial to this minus 1 by x square is there, no? So here we can, bases are equal, we can add their powers, that is x to the power of n minus 1 plus 2 becomes x to the power of n plus 1, this term, and this term, no, it is x to the power of n minus 2 plus 1, etc. Up to last term we write as it is, this minus 1 raised to n minus 1 to the power of minus 1 into n into n minus 1 factorial divided by x to the power of, here bases are equal, no, we can add their powers, it is also n plus 1. So here in this nth derivative of log ax plus b, as I have told you, once again I will write this one here, this one as nth derivative of log ax plus b, we know this one as minus 1 raised to n minus 1 into this one is n minus 1 factorial divided by ax plus b raised to n into a to the power of n. So that is here our, this one is nth derivative of log x only, simply it is. So this one is minus 1 raised to n minus 1 is minus 1 to the power of minus 1 we can take, and into n minus 1 factorial a to the power of n. A is our, so we are finding here nth derivative of log x, no, we just compare these two, in place of a it is 1, so I have not written 1, and divided by x to the power of n. So here what I have done here as multiplying and dividing by n I have taken, so that we can generalize this term. Here it is divided by 1, divided by 2, etc. Now it is up to last term. To get this one, I have written here as multiplying and dividing by n. So just write all the terms as it is here, minus 1 raised to n into n factorial divided by x to the power of n plus 1 log x, and this minus 1 raised to minus 1 is minus, because here if you take this one, denominator becomes 1 by 1, so that is 1 by minus 1, that is minus 1 raised to n into n minus 1 factorial is nothing but n factorial divided by x to the power of n plus 1, then etc. up to, so this term if you want you can write here minus 1 square is plus 1, and this minus as it is, so it is minus as it is, minus 1 raised to n into, you know, n into n minus 1 into n minus 2 factorial, this we know, this 5 into 4 into 3 factorial can also be written as here 5 factorial, like that it is n into n minus 1 into n minus 2 factorial can be written as n factorial. This is n factorial divided by 2 into x to the power of minus x to the power of n minus 1 plus 2. It is, if you add the powers it becomes x to the power of n plus 1, etc. up to last term, that is this is minus, again it is minus 1 raised to n into n factorial, n into n minus 1 factorial is n factorial divided by n into x to the power of n plus 1. So all the terms contains what here, minus 1 raised to n into n factorial divided by x to the power of n. Here we have all the terms contains. So write the remaining terms. This is log x simply, and minus, here it is what else remains, minus all the terms we have taken common, it is simply minus 1, and here it is what else remains, only 1 by 2 remains, no? It is minus 1 by 2, etc. We can generalize this one. Next is minus 1 by 3, etc. Here we have minus 1 by n. So this is the nth derivative of, this is what here, this is the nth derivative of log x into 1 by x is equals to minus 1 raised to n into n factorial divided by x to the power of n plus 1 into log x minus 1 by 2 minus 1 by 3, etc. up to minus 1 by n. So this is the required result of this nth derivative of log x into 1 by x. So I hope all of you understood this one. So in the next video I will solve some more examples. This is the question which appeared in the year 2019. Thank you.